record on this computer. Share screen, screen one. Okay. Now it's 2 o'clock. So just as a reminder that you have that quiz 2 is a thing that you should do before the due date. Due dates for quizzes are hard unless you have a really viable reason as to why you missed it. So I've activated a whole lot of stuff later on for later things in the semester. If you need more time on assignments, please let me know. And I can adjust the due dates, but I added a bunch so that we would have plenty of due dates. The quiz is due on the 15th, so you have plenty of time still. Okay, so let's go ahead and talk about Bruno? No, the thing we're doing today. We are going to, this week in lab, you will be not, so this week in lab, meaning this upcoming Friday and the following Monday, you're not going to be getting a new assignment for lab 5. Lab 4 basically occupies the time. So if you're already done with it, great. Then you've got a bit of a lighter week, but this lab is intended to, again, take some time to do. On Thursday, we will be doing this exercise. Blame Pope Gregory the 13th. But that is what we'll be doing Thursday. And in case you're curious why, it's because it's him for which the Gregorian calendar is named after, and which we are going to pull our hair out about. So for loops and if statements, we'll be working on that today. And specifically, we're going to be working on project 6 from the textbook today, which you can get to by going to Canvas, going to module 5 and clicking on the plan for Tuesday's lecture. And then we can go to, or you can go to the scroll all the way down to project 6, which is computing statistics with Kiva. Again, this will work on, and this will continue on, with us using the for loops, I believe. I don't think you need to have the if else statements other than, yeah, we don't need the if else. Well, we can use them here and you can kind of see how they work, but they aren't necessarily necessary. Department of Redundancy Department. Okay. So let's go ahead and get started. Hopefully you can pull that up. I will drop it in the chat for Zoom for those of you who are here in Zoom, which is quite a number of you. Let's see. So today we're going to be computing statistics on an actual set of data, or rather a subset of a set of data. But once you can work on a subset, it will work for the much larger full-sized set of data. So here we're going to be talking about Kiva. So Kiva is a nonprofit. It does microloans. So you donate your money to Kiva, about $25 or the like, and then you dictate where your $25 are going to be, who your $25 are going to be loaned out to. This isn't a donation, it's a loan. It's expected that the borrower will repay the loan. But these are loans for much smaller amounts than what you could normally, then you would go for a bank, or at least where it comes down to for the cost of living differences. Regardless, it's a nonprofit. It helps alleviate poverty, and they've been around since 2005. So it's cool. I've used it before. But yeah, it's a nonprofit, donation based. And so what we're going to be working off is some data off of loans. So we've got this data over here. It's got an ID, which is like which loan it was, which is for our purposes here, not that important. We've also got a loan amount. In other words, how much was loaned, and this is in US dollars, okay? What country that went to, whether or not they were funded, and for this data set, they're all funded, so this is a not needed data set. A time to raise, how long did it take? I assume this is in seconds that it took to raise the money or the like. And then how many people donated in total, right? And people can donate like as little as $25 or they could go more, but how many people did it take to fund? Like here, this one, which is a $200 loan that went to someone in Paraguay, you had 3 lenders, which means that each of them donated more than, which means on average, there was more than 25 donated per person. Of course, it could have been 25, 25, and 150. We don't know the specifics based off this data set, but that's fine. So there are some really great tools in Python for working for massive tables and data, but we don't need we're not going to really go into this because we're still trying to learn our core Python features, right? What is built into the language, what can we do with it? And they're pointing out that this is a data set that has this is a subset from a data set that has 1.4 million rows. For comparison, the amount of rows this is, and I'm not going to count because I'm a human and therefore likely to fail at that, 25. So we've got 25. But like I said, if it works for this, it will work for 1.4 million. It will just take longer for 1.4 million rows. So we'll do bigger. We'll be working on bigger data sets. As possibly you'll do that in your final project. But right now, all we need to do is learn how to work with our sample set. And then to do this, we're going to represent what we do here is that each of these columns is represented as a list. So in terms of indexes, right? Annotate. This is index 0, 1, 2, 3, 4, 5, and 6, and so on and so forth. Everybody, that makes sense to everybody? So if we scroll down to here, right, you'll see that in loan amount, we've got 1250, 500, 1450. 1250, 500, 1450. And now Azerbaijan, El Salvador, Bolivia. Azerbaijan, El Salvador, Bolivia. So you can see that it matches up. Basically, everything at index 0, in other words, the 0th item in the list, if you will, is that first row. Everything then here, 500 El Salvador, 115708 and 18. That's this row, right? And so everybody get that? This data has already been put in for us. To keep your code easier and cleaner, we will just show you these lists here, but they'll automatically be included for you in later active codes. In other words, they're kind of automatic. They're here. We see them here, but as we go down further, even though they're not showing up, the code's kind of hidden. So watch, I'll show you. Print loan underscore amount and 0, which gives me the item, the first item in that. So, and then it printed out 1250, right? So even though these things aren't explicitly declared, they're kind of loaded in the background for each of the code boxes for us, okay? Now, for those of you, hopefully you have read far enough that you know how indexes work, right? Hopefully you've done that, right? And what we've got here is kind of like subscript notation. For those of you who need a refresher though, right? This is kind of like subscript notation in the sense that like if we had a, if we were in a scary math class and we had a vector, right? We might have something like this. 0, 5, 2 as a vector, right? And then I might say, hey, x X1 gives me, if I were to plug in for X1, it would give me 0. If I were to plug in for X2, it'd give me 5, and so on and so forth, right? So we'd be using subscript notation to get the individual item from that list, right? Now for computer science, we start at 0. So X0 would give me 0, X1 would give me 5, X2 would give me 2. However, on my keyboard, I can't really use subscript notation, much like how in a calculator, in a standard 4-function calculator, you can't do 2 to the 5th power like that, right? You can't write that because wasn't a supported operation for those tiny little font sizes. And like here, when we're working with these font sizes, we don't really have that. Or I can't say X, sub 2. Can't say, and we refer to this as index 2, 0, 1, 2. So it's the third thing in the list. Okay, we can't refer to that like that. Some places you might have done like this, but honestly, but for computer science, the way that works for variables, this would be a new variable called X_2. So we don't use that because underscores and numbers have special meaning. We use those. So to kind of simulate subscript notation, we have this index notation, which is what the brackets are. That's kind of that is my hypothesis is how we got to that. I have not done like kind of a lexical or syntactical research, but that is at least one way for me to remember why this is index operations and what it is. You don't want to do this because parentheses are invoking. Okay, this is an invocation. This is as though X were a function. Common mistake when you're a beginner is to use those parentheses instead of brackets. Brackets are for indexes. Okay, now that I have scared you and possibly scarred, let's go ahead and figure out what is the total amount of money loaned for question 1. So we're going to be answering these questions with our statistics. What is the total amount of money loaned? Okay, so this is just simply an accumulator pattern over loan amount over this variable. So you want to simply, so I'm going to let you do that because after all, this is active learning. Take a minute to do that. You're going to want to write a for loop over each of the items in loan amount and add them up to get your total. It says in order for it to check, it wants you to check it off by putting it into a variable called loan total. Okay, so I'll give you a minute or like 2 minutes to do that, and then I will show you how to do that because we've done this one before, but you know how, I mean, that was like an entire week ago, right? So go ahead and get to it. I'll be back at 2:15. All right, so I know that was quick, but we've got a lot of subproblems to get to. So don't worry if you weren't able to fully remember how to do it. So what we're going to do is we're going to create a variable loan total that they want that we're going to use to store the full amount. Loan total is equal to 0. Is this size good back there or no? I'm not, I don't know how more. All right. So loan total is equal to 0. So for let's call it amount or loan, or each loan in loan amount, what we want to do is say loan total is equal to loan underscore total plus the loan, the amount that was loaned. So we save and run this, and we get a pass here because and we didn't need to print anything out because of the checks. Pass, we use the loan total variable. We use the accumulator pattern. And then it had over here a you may not use sum, and it was checking to make sure basically were you using a for loop, because there is another way to solve this, a one-liner in fact, which is loan underscore total is equal to sum loan amount, which adds up all the items in a list and stores it in here. But again, this is written by people who like to make sure you know how to do things the hard way before you can do it the easy way, because not all programming languages have it the easy way. And you can't always rely on the easy way. But so there is another way to do it. And let's see, can I get away with putting it in comment? No, that's the way unit testers work anyway. So anyway, there we go. So I will share this code, right? So we just simply ask for the loan total. Now, what we're going to want to, I'm going to copy paste this because I know what the next one is, which is the average loan amount. All right, so compute the amount of money loaned, the average amount of money loaned, and store it in the variable loan average, the average amount of money loaned. So let's see, a country. Yeah, so, okay. I think average amount of money loaned. Okay, I think it's just talking about on a per loan basis. So the average amount that each loan is. We'll find out if it was poorly worded in a second. So how do I go from this calculation, which is adding up the total to figuring out how much money was loaned total, to what the average loan amount was? Yes. Yep. Divide by the total number of loans, right? Because the average is just the total number of stuff added together divided by the number of things you added together, right? If you wanted the average of a 6-sided die, you add together all the dots and divide by the number of sides. Loan average is equal to loan total plot divided by, and I know that seems like, ridiculously like, oh, we've been doing averages since middle school or elementary school or something. It shouldn't be, well, you'd be surprised how worried people get in new contexts like coding, right? You'd be surprised how often people expect trick questions or think things are much harder than they actually are. So loan total divided by the length of loan amount. So in other words, the number of things we added together. Okay, so let's see if that works. Yay, we cannot use sum. Okay, that's fine. Now, truth be told, we could totally individually count the number of loans that have been made by having another accumulator and adding 1 to it each time. But we don't need to, because we have this handy dandy length function here, right? That tells us how big everything is, which in this case is 25. So on average, so of our data set, the answer is that 663. Now, does this mean that the average loan size for this or is somewhere around 663 for this 1.4 million data set? No. I mean, it could be if we got lucky with our sample size, but our sample size here is, or our N, as it's called, is 25. It's not a particularly good sample size. And this is something you got to be careful with when you're doing any kind of statistical analysis. You got to know what your sample size is, and you got to know what your bias is. For instance, if you're recruiting from, if you're trying to do a psychology experiment, and you're drawing from a body of undergraduate students, then any conclusions you draw from that experiment basically are really only valid for people who are educated enough to be in college, able to afford college, and have enough free time to go and take a random experiment, and those interested enough in taking, and probably those interested enough in taking a psychology class. Oh, and you're probably all those people are probably fairly young adults because of the age people go to college, right? You can't really draw the same conclusion about, like, say, okay, well, because a bunch of college students do this, this is applicable for old people. That's not to say it's useless. It's generally the first step to getting to saying, hey, I've got some results. Now I want to try it on a bigger population. Please give me funding. One of my personal favorite experiments, by the way, that and this is one called enclosed cognition, which is a psychology experiment which gave a bunch of people smocks, and if they were told that they were smocks, they did fine on math kind of exercises. But if they were told they were lab coats, they did better on the math exercises. In other words, it's kind of you can mentally kind of dress for success. It's very interesting, just kind of what kind of small cues can affect a person. It's weird. All right. So now third problem, store the amount of the minimum loan in min loan and the amount of the maximum loan in max loan. Then store the name of the country that received the largest loan in max country and the smallest loan in min country. Okay, so for here, this one's a bit trickier because we have to use a couple of different variables here. First off, we got to figure out what the smallest loan is. Let's work on the smallest loan. Which of these is the smallest amount? Well, I don't know, I'm human, therefore I can fail at this task by just misreading something. So the smallest loan, by the way, which is the smallest loan, right? That is we can figure that out by using a function called min, which, given a collection, a sequence, a list, all synonyms for the same kind of thing going on over here, gives me the smallest thing in it, right? So if I throw loan amount, and the max does the exact opposite, right? Min loan amount, okay? Oh, hey, right? Tells me, hey, and then it says, hey, you didn't give me a max loan. So this gives me the smallest loan in one line, which is cool. But I also want to find out what country that was for, which country had the $100 loan, which country got that one, which, as their answer is that it is, oh, I keep missing it because I'm human and therefore dumb. Philippines. The Philippines got it. Okay. Right. Again, humans, our eyes pass over stuff. This is why we use computers to sift through data. So how do I get it from one list to another? Right? How do I figure this out? And the answer is that there's a couple of different operations that are built into list. What is one that would be useful here? If I wanted to find out, well, first off, what we have to do is that we have to match the index, right? So this was at index, let's say 4, okay? Then how do I figure out that this was at index 4? Yes. Sorry? Not type, but but we definitely want to use a built-in function. Yes. Yeah, the index function, well named as it is. Loan underscore. So loan amount, and then we can call index min loan, which says, hey, tell me the first index which this number appears at, right? Now, okay, and that is index is equal to and then I will print target. Okay. So it says, hey, it was index 5, so I wasn't actually that far off. So, okay. So this gives me the first index at which this item occurs. Does that make sense to everybody? All right. So what is the only flaw in this? Not that it occurs here, but what would be a possible flaw in my 1.4 million data set? Yes. If you have the same country multiple times, you're on a parallel track. You're correct, but you're on a parallel track. Yes.
If you're missing like one piece of data, then the whole thing's like offset.
That's true. If there was a data set, if we were missing data, that would be very bad. Yes. Yeah, that's it. Yeah. So it's the min amount. We're talking about the min amount rather than the country right now. So the min amount is 100. What if there were multiple countries that had a minimum $100 loan? Right? What if there were multiple countries that match that? And Python says, well, that's your problem. I'm just going to go for the first one. I'm just going to give you the first thing. So index gives you the first thing, and min just gives you the lowest value. It doesn't care where, because as far as this is concerned, 100 is 100 is 100. It doesn't matter where it occurs. And for 100, you don't care either. So okay. So, but that's not a problem here. We don't have repeated amounts. That's good. Yep. And somebody also posted that in chat. Awesome. Great. So now what so we have index. So we have the index that the country is located at. So from here, we should be able to finish the entire problem. So go ahead and take 2 minutes on that, and I will, yeah, until 2:30, and then I'll finish it up. All right, so I just did a bit of doodling on my computer. Yay, touchscreens, right? So the loan amount. So what we've got here is that we've got, right? So what's going on here? We've got a list. It's stored in loan amount, right? It's got some values, A, B, C, D, E, and then at index 5, it has 100, which turns out to be the lowest amount, right? Now, country name also has these indexes as well: index 0, index 1, index 2, index 3, index 4, and index 5. So we just want, so since this is the lowest amount, it's found at this index, which is 5, because it's 0, 1, 2, 3, 4, 5, as informed to us by this index function. And we want to find out what country goes in is at this index. So we want whatever's inside here. Okay, have no idea whether or not that drawing was helpful. I hope it was, but regardless, the answer is as follows. So our min country is equal to country name target, because that is the target index we were looking for, right? We were looking at whatever's at this index, which was provided by this. Similarly, the max amount, I do the exact same thing, only I'm going to replace all instances of min with a max. And always be careful when you're doing a copy paste operation like this. Again, humans and human foliables, right? So save and run, and then we get that, right? So Philippines got the smallest amount and Georgia got the largest amount, got the largest loan. We'll go ahead and share our code again. Okay. So I've already shared it. So if you need it, it will be in your history, but let's go on. So compute the average number of lenders per loan and store it in average lenders. So again, the average lenders, that was the num lenders total. That was this variable up here, right? Like 38 people did the first loan, 18 people were on the second loan, 51 people were on this third loan, and so on and so forth. So we want to figure out what the average was again. So again, that's just a simple matter of iterate. We've done this one already with when we did the average kind of amount. It's the same problem, just over a different data set. For lenders in num lenders total, we're going to do the accumulation pattern, which is total. Okay, I'm going to call it total is equal to 0, and I'm going to say total. I'm going to be a bit more lazy here and do the plus equals rather than saying total is equal to total plus lenders. I'm going to say total plus equals lenders. Okay. It could even be, okay. Or it could be, you can name that whatever you want. You could name it num instead for each number in there. Okay. And then we need to figure out the average, which is, and they want us to store it in the average lenders. Average underscore lenders divided by, sorry, is equal to total divided by the length of num lenders underscore total. Right? Very similar to the earlier problem. It's the same problem. So nothing too exciting there. All right. Here's a different one. Compute the total number of loans made to the Philippines and stored in the variable Philippines count. Okay, so I'll let you do that one. But essentially what's asking is, how many loans were made to the Philippines. How would you figure that out, by the way? Anyone? Like, okay, if I were doing it, if you were doing this by hand, how would you figure it out? Yes. Well, the length would tell you how many there are, how many items total there are. But I'm like saying, when you're doing it by hand on paper, how would you count how many Philippines there are? Yes. Yeah, you just simply count each time it occurs. You don't even have to keep track of the index, right? You're just counting how many occurrences there are, right? Right? You just simply say, oh, Philippines, one, Philippines, add another, Philippines, add another, right? So you just keep going through. And if it's the Philippines, you add one. All right. So there's a couple ways to do that. You can iterate over the country name, use an if statement and an accumulator operator to do that, if you know how to do that. Or you could look up if there is a function built into list to do that for you. So I'll give you another 2 minutes on that one. And that's correct. Somebody's already in chat posted it, but let's go ahead and there is a function that allows you to count things. So go ahead and look that up, or try to do it with the if else statement, or you don't need the else, but try to do it with an if statement. Try it on your own. Give you another 2 minutes on this one. And yes, this one's a lot of little boring exercises, but it helps. We want to get practice on doing these kind of exercises. Okay. So let's see. I'm going to go ahead and just see what the tests are for this. Philippines count is equal to 0. Just going to store that, right? Says over here, you should use the list method, a list method to count. Okay. So I'm going to go ahead and just simply put that comment in to flip it to correct so that I did not do that. Okay, whatever. So the simple one-liner to do this is you say country name, and the list has a count method. And again, if you want to find out more about this, you can go into Python doc list, and it will tell you all about the list that you want to know, all the things that are inside a list. So like append, extend, insert, remove, pop, count the number of times X appears in the list, and list here is the list name in this context. So country name dot count, and then again, I'm going to copy paste Philippines because, again, I'm terrible at spelling. So save and run. Boom. Okay. How would I do it though if I needed to do it manually? Because other programming languages aren't necessarily this nice with a count function. In this case, what I would totally do is I'd say, hey, I'd have to use an accumulator. Philippines count is equal to 0. Country name. So for name in country name. So for each name in the country name list. And the way an if statement works is that it just checks if something is true or not. If it's true, it will activate the code beneath it. If it's not, it won't activate, right? Read more about it in your lecture, in your readings, or in the videos that I've went over these things. But they weren't necessary for today's lecture, so don't worry if you haven't got into it. But we'll want to definitely have these for next lecture. And I should remind everybody for next lecture, even if you're great at programming for the next lecture, it's still going to be a bit of a brain bender. There's nothing simple about there's nothing. This is a non-trivial. There are some operations that are just non-trivial, no matter how experienced a programmer you are. They might be easier or more comfortable, but it's not going to be trivial. So for name in country name, if name equals, so notice I use 2 equal signs there. If name is equal to, not that, if name is equal to, Control C, Philippines, then normally I have autocomplete to handle a lot of stuff for me. Philippines count is equal to Philippines count plus 1. And then I will run it, and that is how it works. So what this does is that it looks at every single name, and it says, hey, is that name exactly equal to this string of text? So now there's 2 kind of, so you're like, wait, there's 2 equal signs in Python? There's 2 equal signs basically in all programming languages, or 2 uses for it. Your single equal sign is the assignment operator, which you should think of as more like an arrow, right? It takes a value on the right and stores it in the left, okay? This, on the other hand, asks a question. This is the equality Boolean operation, meaning it gives me true or false back. It's asking me a question saying, hey, check if these 2 things are equal. Is X equal to 5? You know, in this case, we'd get a yes, and we're getting a yes and no answer, technically true or false. So this number 6 over here would be true. It would give me a true back. And I would do something like answer is equal to, maybe I'll store it in here just to be safe, parentheses or something, but answer is equal, and this would store true or false in this, right? This is an operation just in the same way that less than or equal to is an operation, okay? Right, that's a good way to think about it. So you're looking for a value that's exactly, that essentially is exactly equal to. So if but this also works for like strings and stuff. If name is equal to Philippines, and this is as good as time as any for me to boot up idle and just kind of point out this nice quirk, or to see if we've got a quirk over here. A is, so first off, right, 1 is less than 5. We see that that evaluates the truth, right? Because 1 is less than 5. We're asking the question, is 1 less than 5? Make sense? Convenient, interestingly enough, let's see, A less than B is true. Is A equal to B? No, it's not. Is A greater than B? No, it's not. So how is, in what way is A less than B? Yes. Yeah, it comes earlier in the alphabet. It's, again, answer is the least surprising one. So you can compare strings to see how they compare alphabetically. Of course, it gets a bit weird. Of course, that metaphor does break down when we're dealing with stuff like is period greater than A, is a B, because where does punctuation come in? And it figures it out by ASCII values, right? remember, every character is just simply a bunch of numbers, and it's comparing the numbers there. But yeah, in general, the way we deal with strings is that they're alphabetical. Okay, so this totally makes sense, by the way, checking to see if they're equal to. And again, if you want to, and you can use, you don't really compare strings unless you're sorting them otherwise. All right. So now for each unique country name, let's move on. We're moving on to this next row. And let me share this code. For each unique country name, so here they went ahead and removed all the duplicates, okay? Right? They went ahead and removed all the duplicates. Print a line that shows the name of the country and then the number of loans made in this country, like this, Guatemala 1. So for each country, we want to figure out how many times that country, we want to print out the number of times that country got a loan, right? So in other words, we'll just utilize a for loop to do this expression that we had earlier. So go ahead and take a couple minutes to do that one. And then we'll go ahead and figure out some of the more advanced problems, okay? Okay, so for this one, for name in unique countries. So for each of these countries, what we are going to do is that it's asking us to print out the name, and then we also want to print out how many loans were made of that country, which we do by saying countries. Sorry, country. What is that variable name? I always forget it because it's long. Country name country underscore name dot count the number of times that name occurred. It's actually fairly straightforward, I think. There we go. It didn't need to use an accumulator to add up all the loans. I just simply printed them all out. Oh, so these are the ones that are that I think I grade on, because as you can see, we have half an hour left, and I never know how much time this will take up. So let's take a look at these next ones that are a bit more difficult. So it goes, and because we'll get into some statistics, which seems scary, but not. What is the average amount of loans made to people in the Philippines? So, and then we've got number two, which country was the loan granted to, in which country was the loan granted that took the longest amount to fund? What is the average amount of time / dollars times per dollar that it takes to fund a loan? And what is the standard deviation of the amount of money loaned? So I don't think we've ever got into these problems in class. We haven't been moving a bit quickly today. That's fine. So the index positions for the Philippines are as follows. Conveniently, right? So it's conveniently given us the indices for the Philippines, right? The Philippines occurs at these locations, but we can also assume we didn't have those. That's fine. So use that information to compute the average loan amount for the Philippines. Store your results in the variable P average. So I'll go ahead and create a P. So I'll do it their way first. P total is equal to 0. Index list is equal to for index in index list. Right, so what I'm going to do is I'm just going to iterate over all these because I know that these are the Philippines, right? I'm going to just simply say, hey, and then it says wants the average loan amount. So P total is equal to, and then loan amount of the index. I've never actually done these problems before, so we'll see. And then it wants P average. P average is equal to P the number, so right over here we did the plus equals. There we go. P total is equal to, so this P total, what this does is that we added each loan that was from the Philippines. And we know that the Philippines are at index 5, index 6, index 9. So we grab the thing at we grab the amount at index 5, then the amount at index 6, then the amount at index 9, then the amount at index 11, because that was provided to us. P total is equal to length of index list. And save and run, and that should give us, which is 253.5 and a bit. Okay. So that's if we knew where the Philippines were. But what if we didn't? We had a much bigger data set and we didn't know where all the Philippines were. We'd have to find the Philippines, right? Okay. So let's go ahead and I will comment all this out and kind of get started again. But this time, all I'm going to start with is this variable, P total. Okay. And so I've got to do two things. I got to total up the number of loans I have. And now, because I don't know what the indexes are, or I'm assuming I don't, I also got to count the number of times I see the Philippines. Does that make sense to everybody? Okay. Now I like this problem because, oh boy, there's a total, there are so many ways to do this one. I like this one because there's a total number of ways to do this one. One way is I can go index by index, right? I can manually count the indexes, okay? Like index 0, index 1, index 2, and check everything, right? This is one way to do it. Another way is that one thing I can't do is I can't really use the index operation though. Like I can't use country name.index because it will just give me the first occurrence again and again and again. So what I can do that, so here's one way to do it. I manually kind of work through the indexes. For in range length of it doesn't matter which one I put in, so they're all, because they're all the same. Country name, right? So the country name in this case is 25 long, right? So actually I'm going to put an I here. So the country name is 25 long. So range gives me the indices 0 through 24, which are all the valid indexes, right? So basically we're saying I rather than being, so here, this resembles more what we'd see in other programming languages, where rather than iterating over each item, we're iterating over each index being I. So we're going to start at index 0, then index 1, then index 2, then index 3, then index 4, and so on and so forth, right? But this physically gives us the index. So we could say, hey, name is equal to, there's a ton of ways I'm going to do this, by the way. I'm going to do this like the same thing, like 3 different ways. So, country name I, so because we're at index I, so that's the name. And then we have to use our if else statements here again. Okay, we got to just use the if, there's nothing for it. Only way to do it if we're not using the indexes that are provided for us. So if name is equal to, so if name is equal to, and we're counting Philippines again. So if name is equal to Philippines, without the space, because that actually matters, then we've seen the Philippines once again. So we've seen the Philippines one more time. So what we do is we increase this count by 1, because we don't know how many times we've seen the Philippines, or how many times the Philippines appears in our data set. So we've seen it once. So we increase the count once, so we have the correct amount for our data. And now the total, we got to increment that by p total plus equals. And then let's see, we're looking for the total loan amount. So we would be loan underscore amount I over here. Because hey, if it's if the ith index is the Philippines, then we want to look at the corresponding ith index in loan amount to add to our loan amount. Make sense? And now our average is simply the number of times, the total we had divided by the number of times we saw it. Okay. Save and run. And then divide by 0. Where did I get my divide by 0 error? P count. On line 18, is that because it's a test? Is it testing wrong? What are you looking for? Very interesting. Let's go ahead and see. Integer or division on line 18. Any guesses as to why this might be occurring? I have no idea why. It's not occurring here, right? P count divided by S. So I mean, we've got and we get our stored value. So I'm going to assume that that is just something that is occurring in the code. Or in the background code. Let's just go ahead and back up for a second to this solution, which had no division error over here. right? So here I've got p count, right? And I increment it by 1. So p count is equal to p count. Let's go ahead and be explicit. So we increment it by that amount. No idea why it wants me to do a divide by 0 there. Yes.
Like in the, I don't know if this is what's causing the problem. In the list, it spells Philippines with 1 I and 2 T's. But then in the question.
Oh, that would be it. You're saying that that it misspelled the Philippines. Aha, that would do it. Excellent catch. And that would make sense, because if it's not seeing the if it's not, yeah. So we were getting an error because it wasn't seeing it. That's why. Because the misspell. Okay. All right. So now that we've done that this way, there's another way we can let's see. Yeah, there's really only one other way to do this, which is that we can this statement over here is kind of a bit bulky, right? Everybody kind of agree, range, len, country name, that's a bit of a bulky statement. Just a lot of parentheses going around. And a lot of times when we care about the index, we also do care about the item at it. So what we can do is we can actually do something like this. Index name for each index and name in the range. And then not in range, but I'll simply redo this one as enumerate. Love that word. Enumerate. And then I will just simply replace this with index over here. I believe it will crash if it's not. Okay, great. It did the right way. Or rather, I did it in the right order. So here, what it does for me is that it gives me, it will be easy to see if I print out index and name simultaneously, even though you can kind of guess by my naming of it index and name. So if I do the enumerate, it will give me 2 values. The for loop will go over 2 values, which is the index and the item at that index. So you can get, so this is pretty cool. Very useful if you're familiar with older styles of program, with the older style of for loops. So 0, Azerbaijan, 1, El Salvador, and so on and so forth. So I've got both of them. And now if the name is that, then I can use the index to get the amount, the item at the corresponding amount. Yeah, I think those 2 methods are fine. I was going to try zipped, but I don't need zipped here. All right. Actually, let me check that. Zip Python. Just kind of, I want to doc. Get a lot of stuff, built-in function. Zip. Okay, yeah. Don't really need to do that here because it, oh, wait, no, we can do that. So yeah, the last way to do this, I don't use this too often, but it's, but I see a very easy use case here, is I will take I'll take all this again. If I want, one of the things is that we are using we're essentially going over 2 lists at the same time, right? So if you want to go over 2 lists at the same time, let's go over 2 lists at the same time and ignore the whole thing with trying to figure out the indexes. So for name and amount in zip, country name, comma, loan amount. And this is a really cool function that's built in. You don't really find too much use for it, but when you do, you know when to use it. It's pretty cool, which allows you to go over 2 things at once. So here, I'm just changing the code to be basically name amount. And then I can just do this equals 1. And I can change this to amount. And now what you notice over here is I have no need whatsoever for figuring out what the index is. Let me just make sure it runs. Yep, so here you can see what's printing out is in the for loop is the name and the amount, the name and the amount, the name and the amount. So zip, what allows me to do is says, hey, here's two lists. Obviously they have to be of the same size. And I want to iterate through the items in pairs, right? This is useful when you've got a kind of a situation like this. It doesn't just have to be two lists. You could do 3 or 4, right? But in this case, we just need 2. So here we're iterating through the two lists at the same time. And that's good because like this is, you know, this over here is paired with this. That makes sense to everybody? So we see in Philippines, we had 100. See in Philippines, we had 250. It doesn't combine the lists into a single list. Technically what it's so on a technical level, what it's doing is that it's iterating over both the lists at the same time and pairing to get them together as a tuple. But over here, I unpack that tuple so that we have 2 variables. That's the technical that is technically what is happening here, I believe. What it's like, you can see over here in the built-in function that when with zip, that we have that basically it says for item in zipping these 2 lists together, 1, 2, 3, sugar, spice, and everything nice. It prints out a pair of items like in a coordinate kind of style in between 2 parentheses. That's called a tuple. It's a less flexible kind of list essentially. But since I put 2, but what I did is I unpacked it, which is that I put a comma between them. Yes. Yep. Yep. So it gave me both the index and the name.
Got it. And then the zip takes some type. The zip, what it does is take 2 different lists, and because the way you set it up with the comma there with name, comma, amount.
Yep.
You're telling it I want these 2 variables printed.
Yep. So I've got my first list and my second list, right? And this variable is the name is basically the variable for each item in the first list and the variable for each item in the second list. So it's item 1 from, so it's index 0 from list A, item 0 from list B, item 1 from list A, item 1 from list B. So if they're all paired together, right? It does both index 1s, sorry, both index 0s, then both index 1s, then both index 2s, then both index 3s, and then in both index 4s. Does that make sense? Now you're probably horrified. Is this going to be on the exam? Heck no. Everything I just did with enumerate and zip, totally unnecessary. You saw I did it with length earlier, was totally unnecessary. These just simply, if you familiarize yourself with them, they can be, or know they exist, they can be useful tools later on for you. Yes. A zip, a dictionary allows you to do arbitrary key value pairing, meaning that what the power of a dictionary is primarily being able to throw arbitrary pairs together. So in that way, it's similar, right? You can make arbitrary pairings between items using a dictionary. So that is, yes, similar. I can see how you can get to there. Primarily what you're going to use a dictionary for is for categorizing or counting, and we'll be covering dictionaries. So what is the name of the country that with the loan that took the longest to raise? All right, we've kind of know how to do this one, believe it or not. Longest to fund. Well, what we want to find out is which of these values is the biggest over here, and then figure out what index that is, and then figure out what index that went into in the other one. We could do it in one line, which is going to look very painful like this. Time to raise. So let's see, max time to raise. Oh, what did I? Wow, didn't realize I could do that. Max time to raise. Index. And country underscore name. Okay, I'm going to run this. Name index is not defined. Oh, country name dot bad. And then 249 is not on list. Of course. Time to raise. So I'm just being awful over here. So give me a second to be awful, and I will. But I'm going. But which should this will automatically answer the question I'm about to ask. Name country is not defined. Country name. There we go. Okay. So this gave me the answer. Why is this answer bad? Or sorry, why, this code gave me the answer. Why is this code bad? Yes, I've got somebody in chat who said it's not readable. It's just a bunch of one-line gibberish. It's like a giant run-on sentence, right? It's not comfortable to read. Code is read more than it is written. Case in point, got like 100 students in here. Each of you, I wrote this once, it just got read 100 times, you know? It's very awful looking code. Just because I can do it like this doesn't mean that it's best to do it like this. Just because you can do something, right? Your scientists were so obsessed with what you could do, you never stop to think, should you? So this should be broken up into multiple steps, because as you saw, I was making multiple errors as I was doing it, right? The longer a line is, the more prone it is to making a simple mistake. And I made a lot of simple mistakes while I was doing this. So we need to break this up into steps, okay? So the first thing we want to do, right? What is the name of the country that with the loan that took the longest to raise? Well, what we want to do is figure out what was the value that was the longest to raise, which would be max time to raise. Which I'll just simply call it longest time, because that's the biggest time, right? I could call it longest time, I could call it biggest time, it doesn't really matter. I could call it max time, even. The max, so because this is but throwing in a variable here, in terms of modern day computers, costs me nothing, because memory is cheap, okay? So now that I know what the longest time is, I want to figure out what index that was on the table. Index of longest is equal to time, and I have to pass it right back into this thing. Time to raise dot index of longest time. Okay, and now that I have the index of the longest time, I just need to get the corresponding spot from the country name. So longest to fund is equal to country name index of longest. And let me go ahead and comment that out. Oh, longest to fund is not defined. So, what do we got? Yep, there we go. Yeah, hint, index and max are your friends. So there we go. So All right, it is 3:15. So I will leave off on this message here, right? Just because I could write this and that did do the job, it was really long, which makes it hard to debug. And while you may be a genius right now, like you might come up with this and write it in a stroke of brilliant inspiration right now, you got to think about the you in the future. Because if the you in the future is reviewing your notes, the you in the future is going to look at this and go, wow, whoever wrote this was a deranged madman or madwoman, right? Whoever wrote this was a deranged mad scientist. You know, this is a common experience. The me from the past is always somebody who is completely and utterly insane or incompetent when it comes to the code, right? So make your code easier to read, because for study, at least for the sake of studying, it will make it easier on yourself. Okay. So don't worry about all these other problems. The problems that will get graded are the level 1 questions, but it's worthwhile. I mean, it is a worthwhile kind of exercise if you want to try out the other ones. Now, on Thursday, the exercise, we will be going over we'll be going over Boolean operations over the Gregorian calendar. We will learn in excruciating detail how leap years work. And the entire objective is that we are going to write a program that, given a date in the US format, and I have to specify the US format specifically, given a date in the US format, tell me whether or not that is a valid date under the Gregorian calendar. All right, take it easy. Yeah, Runestone grades are not on Canvas yet. They won't show up onto Canvas until I actually manually import them, which I haven't done yet because I've been busy. So I don't generally have time for demos. Just questions over here. If you haven't had the chance to like demo something and you need to, and like there's no slots open, send me an email and we can work on it over the weekend or something.
I was going to do this weekend. I can do it in my lab.
Sorry?
I can do it in my lab.
Well,
I can do my lab section.
what did you say before that?
It's one to do just today.
That's okay.
Yeah.
So like you can demo after the due date.
Yeah.
That's fine, and there's no late penalty for demoing after. Yes.
On a quiz too.
Yes.
So there was one